Okay, let's discuss this question. Question 6. So two radio towers are broadcasting a radio broadcast at the same frequency and polarized along the vertical plane. So a student driving from A to B states that the radio reception is strongest at point A and gradually decreases at point B. So in question 6a, given that D is 6.8, that is the separation between the two radio towers is 6.8 kilometers, and L is 11.2 kilometers, and the distance between A and B is 1.73 kilometers. So the question is, what is the wavelength of the radio wave? Okay, for this, we have to use the formula for fringe separation, that is delta Y is lambda L over D. So the question is, what is lambda? So lambda will be delta Y times D over L. Okay, delta Y is your fringe separation. That is the separation between adjacent maximum. Okay, so this is the indifference pattern. Okay, between adjacent maximum will be between two maximum lines. This represents the fringe separation. So when the student drives from A to B, the student say it is maximum to a minimum. So this here will be basically point A, and this will be point B. Because the student say that at point B is the minimum, and the distance between A and B is given as 1.73 kilometers. So in other words, delta Y will be 1.73 kilometers times 2 times D. So what is D? Is 6.8 kilometers. Change it to meters divided by L. So L will be 11.2 kilometers. Change this to meters. So using your calculator, you can find that lambda would be 2.1 times 10 to the power 3 meters, or basically 2.1 kilometers. Right? So that's the wavelength of the radio waves. Okay, for B, using the principle of superposition, explain the changes in observation made by the student driving from A to B if the radio broadcast is polarized along the horizontal plane. So initially, right, the radio broadcasts are polarized along the vertical, both of them vertical. Now both of them are along the horizontal. So is there any changes in the observation made by the student? So the answer will be no. The student will still be able to observe maximum interference here and minimum interference here. And the reason is because, okay, in the first part, if the first source is polarized along the vertical, the second source is also polarized along the vertical. So by the principle of superposition, we add up the two vectors up. So to get constructive interference, basically S1 plus S2. So we get a larger crest, right? The crest from S1 plus the crest from S2, we get a larger crest. So this represents constructive interference. So in part B, what happens if the wave is polarized along the horizontal like that? So now this lies along the horizontal. S1 also lies along the horizontal, S1 and S2. So if we add up S1 and S2, what we will get will be a larger crest that lies along the horizontal. So we'll see still constructive and destructive interference as we drive from point A to point B.